the dimension for acceleration? That's good. So this is why in the first homework I told you there's a g with dimension this because that's g. That's the acceleration of a projectile motion if you have nothing affecting the projectile. Alright, so I know if I want time, it should be something like this. To make the coefficient correct, there's a 2, the constant will give me 2, so I just square it. And then I will have to add v naught squared, g squared, divided by g times 2, times g and 2. So I will get v naught squared to g. We can check the dimension again. V naught squared is length squared t minus 2. G is length t minus 2, so blah blah. This thing is a length, which is the dimension of y. So I am confident with my answer, even though I am not very not tired right now. All right, so you can check that. Yes. Right? Yeah.
What happened to the sine theta?
I forget about it because, as you can see, I am very tired. Good. So you should have a sine theta here. So this thing will become b squared sine squared to g. Good. Any other mistake I make? No? Good. All right, so this thing, this whole thing squared is positive, but there's a minus sign, so this thing is either 0 or negative. For maximum y, it should be a positive value for y position. So we want this term to be 0, and this will be the maximum y. The whole thing will only be smaller than this because this will not be changed by time, and time, wherever this is happening, is only going to be a negative number decreasing the value of here. So I know the biggest possible value for y will be this. And it will happen when this thing is 0. When this thing is 0, t and this should cancel. So the time that the projectile reaches the highest point will be the thing here. And again, you can check dimension. As I said, this is a length, and this is velocity is length t minus 1, gravity is L, t minus 2, so t minus 2, t minus 1 is equal to t to the power of 1, which is time t. So I'm confident with my answer. Any questions so far? Again, don't memorize them. You'll need to know how to derive them. All right? Yeah, Olivia?
Is that T max or?
T max, yeah, yeah.
Oh, okay.
This is why I just got ahead. Any other question? Now, let's go with let's go with the time that the projectile is flying. Let's call this time to be t equals 0, and then at t equals t flight, it finished flying and it hit the ground. Now, when it hit the ground, the y position should be 0. So we are solving for a time called t5, which if you plug in into the equation of y, gives you 0. That will tell us how long in terms of time will the projectile fly. Does that make sense? Okay, so if you figure that out, the rest is just math because you know this function is here. So you just plug it back into, so t becomes t5.